Welcome to another fantastic edition of Common Algebra. This video is for Algebra 1, Chapter 13, Section 5, Complex and Mixed Expressions. First, I'd like you to recall something back when you first learned how to work with fractions. You could write a mixed number as 3 1/4. And we understand that that really is 3 whole ones plus 1/4 of a whole. And we can go ahead and add those. If we had 3, I could write that as 3 over 1, so it looks like a fraction, plus 1/4. And once again, we cannot add unless we have common denominators. So to get this first fraction to have a denominator of 4, I'd have to multiply the bottom by 4 and the top by 4. And this would give me 12/4 plus 1/4, which would be 13/4. So we're going to do this process, but we're going to do it with rational expressions. So let's take a look at a few examples. Really, this sentence is just a brief description of what we're doing. In a mixed rational expression, you write the terms with common denominators and then go ahead and add them or subtract them depending on what the problem says. So think of this 4y as being 4y over 1, and I want my common denominator to be whatever the other one is, y minus 2. So I have to multiply the top, I'll try to write this out neatly, multiply the top by y minus 2, and multiply the bottom by y minus 2. And then we simply need to work with the numerators and combine them. So 4y times y is 4y squared minus 8y. And then I have my first fraction ready to go. And then if I'm adding to that a plus 3, doesn't look like there's any like terms to combine, so I'm just going to go ahead and put plus 3 here. And that's the fraction that we get. So this is our answer. Whoa, kind of jumped on me there. All right, example 2. Again, we have just a regular term here, 2b, and I'm going to subtract the fraction a over b minus 7. So I want my denominator to be b minus 7. So I have to multiply the top times b minus 7 and the bottom, which is 1 times b minus 7. And now I have common denominators. If I can just write a b, that'd be great. All right, so I'm going to do this distribution here. 2b times b is 2b squared. 2b times negative 7 is negative 14b. And I'm just going to go ahead and put this minus a here. And this is all over b minus 7. And I was just looking for any factoring to do, not seeing any. So that's my final answer. The next thing we need to learn how to handle is complex fractions. And don't let them scare you. It's just one fraction over another. In other words, it's this top fraction being divided by this bottom fraction. So let's look at a real easy example of this, because we know how to divide fractions once we look at them this way. So if I had 2/5 and I was dividing that by, let's say, 3/7, I could just rewrite that, because this freaks people out. They get all nervous and afraid of this. But this is simply 2/5 divided by 3/7. And we know how to divide fractions. We leave the first fraction the same. We change the divide sign to a multiply sign, and we do the reciprocal of the second fraction. And then this just becomes 14/15. Then we multiply straight across. So don't be afraid of a complex fraction. Just rewrite it, if you'd like, as this, and then leave the first fraction the same, change the divide to a multiply, and do the reciprocal of the second. All right, let's try a few of these. So I just took this first example, x plus 2 over x squared, and I just wrote that first fraction. And then I'm dividing that by the second fraction, and then this just doesn't look as scary. So now we follow the same process we've always followed for dividing fractions. We leave the first one the same, change the divide to a multiply, and do the reciprocal or flip the second one. Well, and this one ended up with some nice canceling. Just going to remind you that you can only cancel the entire binomial or nothing at all. So this x plus 2 cancels, leaves me with ones. This x divides out one of these x's, and so my final answer is just 1 over x. All right, in this last example, let's see if you guys are okay with kind of skipping this step right here. We know that it's the top fraction divided by the bottom fraction. So how about if I go ahead and write this top fraction and jump right to this step here where we are multiplying by the reciprocal of the bottom. And if that's not okay with you, you can still put in that first step of dividing the fractions. But we are multiplying by the reciprocal. And so now we got to think back to what we learned earlier about factoring. This numerator is the difference of two perfect squares, so it factors into x plus 3, x minus 3, and I still have 4x on the bottom. I have 8x squared in this numerator, and x plus 3 here. I'm going to put that in parentheses just to remind us it's a binomial. It's all or nothing. So this x plus 3 cancels with this x plus 3. 4 goes into itself once. 4 goes into 8 twice. This x goes into itself once and takes out one of these x's. So now I'm looking at this denominator and I just have 1 times 1 times 1. So the denominator is just 1. So my numerator is, I have this 2x left, and I have an x minus 3 left. And we can leave our answers in factored form. So now we're no longer going to be afraid of complex fractions. We can handle it. All right, now you have the knowledge you need for section 13.5, so have fun with math.